So now let us discuss very important topic, energy and types of energy. Already I have explained you energy means capacity to do work. Like in case you have got 50 rupees in your pocket, you have capacity to buy anything from restaurant for up to maximum 50 rupees. So in case some work has been done on the body has got capacity in order to do the work. This capacity of the body to do work is called energy. Now, energy of a body is of two types. One is due to its position. In case a body is kept at a very high altitude, and if it drops from that altitude, because of its position, when it falls on the ground, it will hit the ground with very high energy. Or in case you take a bullet, if a bullet is fired from a gun, due to its high velocity, it has got energy, it can even pierce a wall. So these two types of energy, due to its position or due to its motion, is called mechanical energy. Okay? So you see, energy possessed by a body due to its state of rest or motion is called mechanical. It is of two types. Is due to its position, whereas kinetic energy is due to the motion of the body. Now let us learn about what is potential energy. Potential energy is also of two types. One is called gravitational potential energy and other is called elastic potential energy. Now I will explain to you gravitational potential energy. Energy of a body due to its position is called gravitational potential energy. For example, if a body is kept at a height h, then we say its potential energy is mgh. Why? Because we have overcome the earth attractive force mg, which is weight of the body, and the displacement is h, so work done is mgh. So this work done gets stored in the body at height h. So the energy possessed by the body due to force of attraction is called potential gravitational potential energy. As the distance or the height of the body from center of the earth increases, the potential energy decreases. It follows inverse square law of distance. So if I double the distance, the potential energy will become 1/4. Now, so if we take the body to infinity, then we say the potential energy is 0. So infinity is considered where there is no attractive force of earth. Now gravitational potential energy at any point, suppose at point A, is the amount of work done by force of attraction of earth in bringing the body from infinity to that point. So work has to be, as the work is not done against this force. Suppose I am starting the body from infinity and bringing to the point A, the earth is attracting the body, I am not doing any work. So always attractive force is negative. So the potential energy at all points between infinity and center of earth has negative potential energy. Now, so if the point is much lower, then it will be more negative. Why we say the energy is negative? Because if I to now move the body from point A to infinity, I will have to do the work. Suppose at point A the potential energy is minus A, then I will have to do the work plus A, so that I can take it to infinity, as minus A plus A will be 0. because at infinity the energy is zero. So that is why all bodies in Earth's atmosphere are having negative potential energy. But many times we consider Earth surface as having zero energy. So if I take the body to a height h, what is the amount of work done? mgh. So we say the body is having potential energy is mgh. But strictly speaking, scientifically, the body's potential energy has increased by mgh. Okay. So this is about potential energy. Now I will explain to you what is elastic potential energy. When an external force is applied to a non-rigid body, it gets deformed due to change in its size and shape, because the distance between molecules may decrease in case I am compressing it and may increase if I am stretching it. So when I remove this force, the energy stored in the body gets released and the body is able to do the work. So this energy stored in the body is called elastic potential energy. If you take a spring, you compress the spring, the energy is stored in the spring, and as soon as you release the hand, the spring will bounce back and give out the energy that was stored in it. Is it okay? So now I will explain to you what is kinetic energy. As I told you, kinetic energy is energy due to motion of the body. Now motion is of various types. You can have translational motion, you can have vibrational motion, you can have rotational motion. So corresponding to each type of motion, there is a kinetic energy. So energy due to translational motion is called translational kinetic energy. Energy possessed by the body due to rotational is called rotational kinetic energy, and energy possessed by the body due to vibration is called vibrational kinetic energy, and sum of all these three will give the total kinetic energy. Now let us try to derive the formula for translational kinetic energy. Let me take my pen. Now you consider body of mass m. So I am considering a body of mass m. I am considering a body of mass m. It is moving with velocity v. Now the body is moving with velocity v, so it has got certain amount of kinetic energy which we denote by k. Now if I bring a body is moving in this direction, this is the velocity v in this direction, I am bringing an opposition force in the opposite direction. Now this force will stop this body. This force will stop this body. After how much distance the body will travel before getting stopped? So that distance is in my displacement s, and the uniform retardation is a. So a is my uniform retardation because I am applying a force F in the opposite direction, so that the retardation it is getting stopped after a distance s. Initial velocity v. So whatever kinetic energy the body was possessing, it will become zero when it will come to standstill. So whatever the kinetic energy the body has lost, why? Because that is the work that I have done. So work done by the external agency or by the retarding force is equal to the kinetic energy of body. So that's what I have written. Work done by retarding force is equal to F into S, force into displacement. and that is the kinetic energy of the body in magnitude. Now when I applying this force F, how much retardation it will produce? That will be given by Newton's second law of motion. Force is equal to m into A. So these are my two fundamental equations. This is my force equal to mass into acceleration, and F into S is equal to K, kinetic energy of body. Now if I use a third equation of motion, v square equal to u square plus 2as, final velocity is 0. So v is 0. And what is u? U is my initial velocity. So what I will get? Initial velocity was v. So I will get v square minus 2as is equal to 0. Why minus has come? Because direction of v is in the forward direction, but my acceleration is in my opposite direction. If this is velocity v, velocity is going on decreasing, so my A is in this direction. Acceleration is in so A is my negative, so v square minus 2as is equal to 0. Then this will give me my S is equal to v square upon 2a. So I have got the value of S. So this is the value of S I have got, v square upon 2a. This is the value of force I have got. So now what I will do, I will substitute the value of force and S in this equation. So I will get K is equal to F. What is F? M into A. Then what is my S? V square upon 2a. So what would be my, if I substitute, I will get K is equal to force is m into A and S is v square upon 2a. If I simplify, I will get half mv square. Therefore kinetic energy of body is equal to half into mass into velocity square. This is the derivation. So in case I make the mass of my body double with the same velocity, then my kinetic energy will also get doubled. But if I double the velocity for the same body, then my kinetic energy will become 4 times, because it is velocity square. If I make my velocity 3 times for the same body, then kinetic energy will become 9 times. So this is the very most fundamental formula of kinetic energy is half mv square, which you will soon learn. Now let us derive a relation between kinetic energy and momentum. What is momentum? M into V. So again I am taking the body of mass m. This is the mass of my body. This is the velocity of my body. So my momentum would be m into V. Momentum is written by P. So P is m into V. So to square both the sides, I will get V square equal to P square. I am bringing m here. So I will get V square is equal to P upon m the whole square. Now what is kinetic energy? Half mv square. So if you simplify this, you will get V square equal to 2k upon m, and so you will get P is equal to P is momentum of the body. So you will get P equal to root 2. You will get P equal to square root of root 2mk. This is P equal to root 2mk. This is just algebra. Okay, so this relation is also very important. It is used in, it will be useful in solving numericals. Okay, so P is equal to root 2mk. Is it okay? So you revise this before we proceed further.